So we're going to start with something called the change of base formula, which is something that you studied last year. And go ahead and copy this down into your notes. The change of base formula allows you to evaluate any logarithm in your calculator. And it looks like log base a of x equals log of x over log of a. When I work with this formula, I always remember that the base number is in the bottom. And that sort of little alliteration is something I use to remember, like, which way do I write that? Okay, which number goes in the numerator, which number goes in the denominator. So I always remember base is on bottom. And like I said, we're going to use this when we want to evaluate logs that have different bases that we don't have buttons for on the calculator. So you know you have two log buttons, right? Log and natural log. What's the base for the log button? Base 10. Okay, that's called the common log. And what's the log or the base for the natural log? Base E. Right? If you did your homework, you were rewriting all of those with base E. Okay. So up until you have the change of base formula, which you already know from Algebra 2, you could really only do two types of logs in the calculator. Now with the change of base formula, we can do log base 2 of 12. We don't have a button for log base 2, but we can use the change of base formula to do log base 2 of 12. That would be log of 12 divided by log of 2. Now, one thing to note about your calculators, and you probably experienced this last year in Algebra 2, most calculators will bring up a parentheses, so it's really important that before you hit divide, you actually close that parentheses for 12. So maybe get out your calculator real quick and make sure that you can get the correct answer here. I get 3.585. So the log base 2 of 12 is equal to 3.585. If you think about your circle method for rewriting in exponential form, that would say that 2 to the 3.585 is equal to 12. And if you were to type in that exponential expression into your calculator, it would be very close to 12. 12.000 something. The reason why it wouldn't be exactly 12 is you had rounded it, right? Okay, so if you put in all the numbers, it would be even closer. And use that, like I said, anytime you can't evaluate a logarithm. So like, 2 to what exponent equals 12, I don't know, because 2 to the third is 8 and 2 to the fourth is 16. It's somewhere in between 3 and 4, and this will narrow it down really fast. We okay with change of base? Okay. Okay, the other three properties are the properties that I was talking about earlier, where like you would use these properties to maybe simplify or change an equation so it's something easier for you to work with. And like I said, we may not necessarily see the immediate benefits of having this skill, but it could come in handy later. So there are three properties of logarithms. Remember that logarithms, we said yesterday, were really just exponents. So if logs are exponents, what we're describing here are also basically the properties of exponents. And when we refer to like properties of exponents, do you remember in Algebra 1, you had rules for like, what do you do with your exponents if you have x to the third times x to the fifth? You add your exponents. And what do you do with your exponents if you're dividing? You subtract them. And what do you do with your exponents when you take one raised to another? You multiply them. So those are basically the three properties, okay, that we're talking about in the properties of logarithms, but now they're going to be written in logs instead of exponents. So my product property says the log base a of u times v. And I'm using the same letters that the pre-calculus textbooks use. If you did this last year in Algebra 2, you probably used like x and y instead of u and v. This is the product property. It's talking about if you are multiplying two numbers or two or more numbers behind a log, then think about multiplication up here. It turns into addition of your exponents. So we can break this up. It'll be 2 logs, both base A, being added together. So log base B of U plus log base B of A. Break it up. They each get their own log, same base, separate. Did I say base B? Okay, sorry. That's because I teach algebra too sometimes, so I'm used to that. Base A of B. Sorry. And then if you go this way, it's called expanding your log. If you see 2 logs that have the same base that are being added together, and you go this way, it's called condensing your log. Do you remember those phrases? So you can go either direction in the property, put them together, take them apart. What do you think will happen when you do the quotient? It'll turn into subtraction. Very good. So log base A of U minus log base A of V. Got my bases right that time. And I can, if I see 2 logs that have the same base that are being subtracted, I can put them together in 1 log, but then the 2 values get divided. And so I can put them back together. The power property says the log base A of U raised to the n is equal to, and remember when you take an exponent raised to a power, you end up multiplying the exponents. So we would do n times log base A of U. And those are your 3 properties of logarithms. So you're going to be using those 3 properties of logarithms here in just a moment with your small groups to work out some examples. I would encourage you to put these examples in the notebook right after this. Use it as examples for your notes. You'll be checking with me as you work so that you can verify that you have the correct notes. A lot of times you'll see me, just so you're aware, on the board, like I'll circle exponents and drop them in front of logs, or I might find a number that's being multiplied in front of a log, and then I draw arrows going back with exponents. So when I work with the power property, I do a lot of those arrows and things. So if you see me working anything out with that, that's what I mean. Okay. So here's how it's going to work. Each of you are at a table, and you are going to be in a group, okay? And you'll send someone from your group to go. You can run to the restroom, Maggie. You'll go up to the table. You'll grab the first card. You'll take it back to your table, and then you guys will work out the problem. Once you guys all agree on an answer and you all have the same answer, send someone up to me, and I will check their answer. And I'll either tell them, yep, you're right, you can go grab the second example, or I'll give them some kind of feedback and I'll take it back to the group, and then you'll rework it. And then if you get it right, you'll bring your card up here, turn it in, and then you'll pick the next card from your group. Okay. Groups are labeled A through F, so we'll just do A, B, C, D, E, F. Okay. So send someone up to grab your first example and get started.
Is there a winner to this game?
No.